Welcome to the session 4 of Fluid Mechanics, Unit 2, Fundamentals of Fluid Flow, Kinematics. Let us derive the continuity equation in 3 dimensions. Consider a fluid element A, B, C, D, E, F, G, H. This is the fluid element in a fluid flow of density rho. Let the dimension of the fluid element be dx, dy and dz along the x, y and z direction respectively. Let the velocity components be u, v and w along the x, y and z direction respectively. The mass rate of fluid flow entering the section ABCD along x direction is given by rho into area into velocity in x direction. So rho is the density, area of this side, that is ABCD. It is like a rectangle. So area will become dy into dz. This is dy and this is dz. Into the velocity in x direction, we can write it as w. Next is the mass rate of fluid flow leaving the section EFGH. Okay, along the x direction is given by rho into u dy by dz plus dou by dou x of rho u dy dz into dx. So we can see there is a gain of mass from when the fluid is entering the section ABCD to leaving the section EFGH. So let us determine that gain in mass along the x direction. So it is mass through ABCD minus mass through EFGH per second. So we'll arrive the equation as dou by dou x of rho u dx dy dz. Similarly, we can determine the net gain of mass in y direction, which is coming as dou by dou x of rho v dx dy dz. Similarly, in z direction, it is dou by dou x of rho w dx dy dz. Therefore, let us calculate the net gain of masses. We have to add all the three gain in mass in all the 3 directions, that is x, y and z. So we'll arrive the equation 1. We end up with the equation 1. Since the mass can be neither be created nor be destroyed, the net increase of mass per time in a fluid must be equal to rate of increase of mass of fluid in the element. But the mass of fluid in the element is rho u dx dy dz, and its rate of increase with time we can write it as d by dt of rho u dx dy dz. Okay, call it as equation number 1. By equating equation 1 and 2, so this is the equation we will get. Since the steady flow, for steady flow, dou p by dou t is equals to 0. If you substitute that value 0 here, so the equation is reduces to dou by dou x of rho u plus dou by dou x of rho v plus dou by dou x of rho w will be equal to 0. If the fluid is incompressible, again this rho become constant. So if you substitute that in the above equation, the equation reduces to dou u by dou x plus dou v by dou y plus dou w by dou z will be equal to 0. So this is the continuity equation for 3 dimension. Similarly, for 2 dimension, we will consider only two, that is x and y. The z direction factor will not be there, that is dou u by dou x, dou w by dou x will not be there. So the equation reduces to dou u by dou x plus dou v by dou x is equals to 0. Next is velocity potential function and stream function. Velocity potential function is represented by phi, and it is a scalar function of space and time. Okay, so here you can see the velocity potential for u, that is u is equals to minus dou phi by dou x, v is equals to minus dou phi by dou y, w will be equal to dou phi minus dou phi by dou z. It is a negative derivative with respect to any direction, gives the velocity component in that direction. Okay. The property of velocity potential are, if the velocity potential exists, then the flow should be rotational, and it also satisfies the Laplace equation, then it represents a possible case of a fluid flow. Next comes to stream function, which is represented by psi. It is also a scalar function of space and time. So it is the partial derivative with respect to any direction, gives the velocity component at right angle to that direction. Okay. So dou psi by dou x will be equal to v, dou psi by dou y will be equal to minus v. The property of stream functions are, when the stream function psi exists, it represents a possible case of a fluid flow, and it satisfies the Laplace equation, then the flow should be a rotation. Next is equipotential line. It is an imaginary line along which the velocity potential remains constant. So phi will be equal to constant. Since for a two-dimensional steady flow, phi is a function of x and y. So d phi will be equal to dou by dou x, or dou phi by dou x into dx plus dou phi by dou y into dy. Substituting the value of u and v, we will get it as d phi will be equals to minus u dx minus v dy. Again, dy by dx will be equal to minus u by v, where dy by dx represents the slope of the equipotential line. Next is line of constant stream function, or a streamline. It is an imaginary line along which the stream function psi remains constant. Again, psi is also a function of x and y. For a steady flow, we will get this equation. Okay, since it is a function of x and y, we have to partially derive it. Okay, substituting again the value of u and y in this equation will arrive as d psi will be equal to v into dx minus u into dy. So this v into dx will be equal to u into dy. dy by dx will be equal to v by u, where dy by dx is called as slope of the streamline. Next comes the relationship between stream function psi and velocity function phi. So these are the relationship. U is equals to minus dou phi by dou x will be equal to minus dou psi by dou y. V is equals to minus dou phi by dou y will be equal to dou psi by dou x, where this phi line and psi line intersect orthogonally. Next is flownet and its application. What is flownet? It is an important tool in analyzing two-dimensional flow, irrotational flow problems, or it is a grid obtained by drawing a series of streamlines and equipotential lines, is known as flownet. The flownet construction is restricted by certain condition. So they are, the flow should be two-dimensional, the flow should be steady, and it should be rotational. It should not bound by gravity force. Let us see what are the uses of flow nets. Flow nets are used to determine the streamlines and equipotential lines, and it is used to determine the quantity of seepage, upward lift pressure below the hydraulic structures like dam, gates, locks, etc. And it is also used to determine the velocity and pressure distribution for given boundaries of flow. and to design the streamline structure and to determine the flow pattern near the well. So these are some of the methods of drawing flow nets. Okay. Analytical method, graphical method, electrical analogy method, hydraulic method, relaxation method, viscous analogy method. So let us solve problems on velocity function and the stream function. The first problem, determine the velocity function is given by psi is equals to 5 into x square minus y square. Calculate the velocity components at the point 4 comma 5. We need to determine the velocity components. So let us write dou phi by dou x will be equal to 10x. Okay. And dou phi by dou x will be equals to minus 10y. So if you partially differentiate this with respect to x and y, we will get this. So velocity component u and v are given by u is equals to minus dou phi by dou x, which is equals to minus 10x. V is equals to dou phi by dou y, which is equals to minus of minus 10y, which is equals to 10y. So the velocity components in at the point 4 and 5. So you have to take x is equals to 4 and y is equals to 5. If you substitute in this equation, you'll get u value as 40 units and v value as 50 units. So next, second problem. A stream function is given by psi is equals to 5x minus 6y. Determine the velocity component and also the magnitude and direction of the resultant velocity at any point. So this is the psi is given psi function which is equals to 5x minus 6y. If you partially differentiate this with respect to x, you will get dou psi by dou x will be equal to 5 and dou psi by dou y is equals to minus 6. So now let us determine what are the velocity components, that is u and v, which is equal to u is equals to minus dou psi by dou x, which we get it as around 6 units per second. Similarly, v is equals to dou psi by dou y, which is equals to 5 units per second. So resultant velocity will be square root of u square plus v square, which is coming around 7.81 unit per second. And the direction, that is tan theta, will be equal to v by u, which is equal to 39 degree 48 minutes. Thank you.